Good morning, students. In this today's lecture, we will study the application of uniform circular motion. Students, when a vehicle is moving along, you can see here vehicle is moving along a horizontal circular track. You can see in the another diagram, there is a circular track. When vehicle is moving along a circular track, but that track is a horizontal, not inclined. We will come across when track is inclined. Now we will consider a vehicle of mass m perform circular motion along a horizontal circular track. The radius of circular track is small r, and center C. You can see in this particular diagram also center C, and that circular track, radius of the circular track is small r. Students, when vehicle is performing circular motion along the horizontal circular track, we can observe forces acting on the vehicle. Here we are going to consider vehicle is a car. If mass of the car is small m, then its weight, you can see its own weight is always in the downward direction. So mg, its own weight, you can see here mg is its own weight. When its own weight is on the road, there is an opposite reaction is also there. This n is called normal reaction, and we can see the direction of this normal reaction is vertically upward. So we understood two forces acting on the car is one is normal reaction, which is vertically upward, and mg is vertically downward. When car is moving along the circular track, one more force is acting along, we can say, horizontal direction, and it is towards the center. That force is coefficient, that force is called friction, and this friction force is very necessary to avoid from outward slipping and skidding of the vehicle. If this friction won't be there, then car will slide. Means indirectly friction will help us to move a vehicle along the circular track. Due to friction, Fs, car is performing circular motion. The force necessary for circular motion is called centripetal force. So students, Fs over here will provide necessary centripetal force. So students, we observe that one vertical and one downward force is balanced. So N is equals to mg, and horizontal force Fs will provide necessary centripetal force. What is the necessary centripetal force? The formula for necessary centripetal force is if vehicle is moving along the circular track with a velocity v, then what is the centripetal force is given by mv square by r. Students, one more formula for Fs is also there. If I consider mu is a coefficient of friction, then Fs is given by mu s into n also. So students, let us see the mathematical expression. First, balance force is n equals to mg. Say this is equation number 1. As I told you, Fs, that coefficient frictional force will provide the necessary centripetal force. Formula is mv square upon r. If I increase the velocity of the car, then v will go to the maximum value. Then then frictional force also be maximum, is given by mv square max upon small r. But as I told you, when frictional force is maximum, then another formula for frictional force is coefficient of friction multiplied by normal reaction. If I equate from 1, 3 and 4, we observe that mv square max upon r is equals to mu s n and here n is equals to what, students? Mg. I am going to replace n by mg. We observe that here mm get cancelled and remaining terms are what? Mu s into g. Students, upon r I will shift over there. Then what is the formula for v square max? Mu s, that is coefficient of static friction, multiplied by g, that is what, acceleration due to gravity, multiplied by small r. If I take the square root, then v max is given by maximum velocity, so that what car can travel along the circular track is given by under root, circular horizontal track is given by under root of mu s multiplied by g multiplied by r. Hope so you understood the derivation for maximum velocity along the circular horizontal track.